Login accepted.
Hello, everyone. Welcome to my talk. My name is Dervis, and today I'm going to speak about Java and Haskell and the similarities between those two languages. So this is the first conference I'm speaking at after the long period of the pandemic, and I just have to say that I'm very thankful to be here, and especially in Krakow, a beautiful city. If there is anything that you will see during the talk that you think can be better, please come to me and give me feedback after the talk, because I really want to get better at this, so don't feel shy, just come and give me the feedback. So I work as a principal officer in the Norwegian government. I lead a team of developers, and I am also very active in the Norwegian Java user group in Oslo. You see on the t-shirt I have. And I'm also doing other meetups around the city. So I work in the Norwegian government. I work for the Norwegian Labor and Welfare Administration. And in the past 5 years, we have been really transforming the organization. We went from large, short-term projects, and we transformed the organization into long-term product development. And a part of that process has been that we hired our own developers, and we also allowed the developers to choose their own programming languages, technologies. We basically gave them much more flexibility in the product development. And as a part of that process, we also started looking into functional programming. And when I started looking at functional programming, I really had two options. I could go for one of the hybrid languages, Scala, Kotlin, or even anything else. Or I could go purely functional. So, because when you have languages where you can escape, sort of say, and do things object-oriented, you really don't get the feel of how a purely functional language really is. So that's what I did. I jumped into it. I started looking at Haskell, and I got inspired by Walt Disney and this quote here. The way to get started is to quit talking and begin doing. So that's what I did, and I ended up something like this. I was basically lost, not really sure how to orient myself. But as the time went on, the more I looked into the language, I started seeing some similarities and huge differences, of course. And I started to see and understand many of the concepts better. So that's what I'm hoping to share with you today, what I have experienced and learned. But I do have to underline this important thing here, that is just a drop in the water, because it's really not fair for Haskell, I have to say, just by comparing it to Haskell, because they are totally different languages, and you need to reset your mind when trying to learn it. So the reason I'm talking about this is because I see where Java is heading at. I want to also share that with you and tell you that. So, and also in Krakow last year, there was the Trends in Functional Programming Symposium. And this is actually one of the research communities. And notice the name of the editor here, John Hughes. John Hughes is one of the long-term contributors to Haskell, and a very important name historically, and I take a look at it. And this talk is not about these things. I'm going to keep it simple. And I'm not here to evangelize Haskell or any other, so I'm just here, I hope, to inspire you. Okay, so a brief summary. There is a lot of bullet points here. I just want to tell a few important ones. Haskell is immutable and lazy. It's strongly typed, and it's garbage collected, actually. It has a stack and a heap too. Ahead of time compiled. It compiles to binary files. Java, as you already know, Java is strict, statically typed. And strict means that functions and methods are evaluated first, then passed on to other functions and methods. And some notable names on the Haskell side here, John Hughes, as mentioned, and Lennart Augustsson, they are both professors from Chalmers University in Stockholm. And then Philip Wadler, does anybody know who that is? He's one of the guys who introduced generics in Java. And Simon Peyton-Jones, of course, one of the writers of the Glasgow Haskell compiler. Very important names, so take a look at them. So Java is about clear, readable, and reliable code. It has never really been a goal itself of the Java language to have as less code as possible and abstract as much as possible. And as Brian Getz said it, make it easier to build and maintain reliable code. That's why people continue to use and trust Java even after so many years. And in the last couple of years, we see Java adopting the concepts, well-known concepts from functional languages. All of those JEPs here is going to be a part of the language, except the last one, JEP 405. Record and array patterns. This is a particularly interesting JEP that's going to be a part of Java, hopefully soon. So I really recommend you looking at it. Oops. And what it's about deconstructional patterns. Like I'm going to show you some examples of this from the Haskell code. Okay, so Haskell. Haskell is strongly typed. It has a very powerful type inference. Haskell provides you a lot of syntactic sugar in the language. It allows you to write extremely expressive code. And libraries is getting increasingly better. One of the build tools, Stack, which works quite well. And I have seen an increasing community around Haskell. And in the Norwegian industry, I have seen it also being adopted a little bit more. One of the biggest ad search companies in Oslo have been actually using Haskell in production for their backends. And 1.5 years ago, when I did this talk for the first time, I also said that tooling is getting better. Well, yeah, it can get better. And Haskell is extendable language. It guarantees you laziness and immutability. Haskell is all about expressions, and expression is something that always results in a value. And the value in Haskell is a first-class citizen, so you can pass everything around. And it's really not easy to introduce side effects into your Haskell code. It's still possible. And you can also enable additional features of the language by using something called pragma. Pragma is, you can enable them on the command line, or you can enable them within per file. So let's look at compilation and runtime system. This is Java. You may have seen this several times before. The Java source code is read into the compiler. There is not much happening on that first stage over there. The code is turned into bytecode. Then when it's read into the JIT compiler, a lot of optimization happens. And also when your code is running, the JVM will also turn specific parts of your code into machine code in order to further optimize the code. This is the Haskell compiler. It's a simplified view of it. Your source code is read into the compiler again. It's turned into something called core. Core is itself a tiny functional language. A lot of it's used for optimizing the code. From there, it turns into STG code, which is also called G machine code. And that's the foundation for the code generation, and it will turn that code into C++. And it's actually called C++. And it's an abstraction of, it's a subset abstraction of C. From there, you can choose the target LLVM, machine binary file, or even C. But I have to underline also that the C code generation from Haskell is deprecated from version 7 of the Glasgow compiler, so it's not really a part of the Glasgow compiler anymore, even though it was possible before. Simon Peyton Jones, he wrote this article about the compiler. I recommend reading this. There's a lot of details in this article about the compiler. So the Java runtime system, the class file is read into the class loader, which is then fed into the execution engine, and it's mapped into the heaps and stacks. And this is also probably familiar to you. Haskell, the opposite thing happens here, and this is kind of interesting because Haskell does have a VM. And that's the STG machine. And the interesting thing here is that the compiler generates for you executable binary file. The compiler libraries is compiled into the executable together with your source code. Your source code would be the STG program code together with the libraries and the STG machine. And then it's also executed in the Haskell execution context, which is responsible for mapping the cores and CPUs and so on. So, very simplified model. The Java source code is read into the JVM. However, in Haskell, the runtime system is compiled together with your code to executable file. So, some important differences in the language. And Haskell guarantees immutability out of the box. It has the concept that you may have heard about purity and impure code. You will also hear this thing, dirty code, impure code. And the impure code is very often handled in monads. I will not talk about monads. That's a whole university degree, I think. And I was talking to a conference participant who asked me this one question. He said, do you know why Haskell programs never fail? Well, Haskell programs never run. But we do need impure code, actually, to run our programs. And that's what we use the monad for here, the IO monad. Each line is read in sequence and evaluated in sequence. And that's how we basically start and deal with input and output from our programs. And then lazy evaluation. Again, a lazy evaluation is you get this out of the box unless you choose some data structures that I will tell you about this later on. Lazy evaluation is about Haskell reads your functions and it will then delay the evaluation for a later point, and then at some stage, if Haskell decides that it really isn't necessary to evaluate the function, it will skip it, and you will save processing, and you will save time, and Haskell can optimize the code even further. I have a code example. This code example is showing Java. I took it from the legendary Venkat Subramaniam's one of his talks. Let's see if it loads. Doesn't look like. The way, because Java doesn't have the concept of lazy. So that means that if we want to use lazy in Java, we have to utilize supplier. In the code example, which is online, because it doesn't look like it's going to load here, you can take a look at the code, and you'll see how to use the supplier to get this working. Let's continue to basic types. So Haskell has many of the same structures that you might have seen from Java. You will notice that Haskell, there is nothing called long here, but the int64 type will map to long in Java, and then int8 will be the same as a byte. Haskell does have primitives. The primitives they have this hashtag in the end, and you can also do bit manipulation here. However, in Haskell, it is not actually recommended to using the Haskell's primitives, because Haskell's primitives doesn't have lazy and immutability built in. So the basic types, the regular types, does have that. But when you use those basic types, Haskell will try to optimize your code further whenever it's possible. And the bit manipulation is in the data bits package that you can import. So these are arrays. Each line on left and right maps to each other. And arrays in Haskell are immutable. So they are immutable in Java, but in Haskell, they are immutable. So each change in the array will result in a new copy of the array. There is one particular thing that I find interesting in Haskell. You'll see it on the line where you see the map. There, on the Haskell side there, you can choose to have the indexes of the array can be actually something different than numbers. So if you choose, you can use letters for that purpose. And by the way, the syntactic construction that you see on the Haskell side here is list comprehensions. List comprehensions I have seen it in other languages, also in Scala and other languages. So, okay, Haskell's arrays are actually a whole talk on its own, and they are extremely powerful structure in Haskell. You have to import the data array package in order to work with them. Now it loaded. It's a little bit small text, I'm sorry about that. Here you see the letters as array indexes. I created basically a simple chessboard. You can see this code online if you like to. It's some simple things. Let's see. Algebraic data types. How many of you in the audience have tried or worked with Haskell before? Some? Yeah? So I just remind you that if you see anything wrong, please tell me later on. Algebraic data types can be broken into two particular things, sum types or product types. The examples of sum types is Java's enums, for example, Haskell's data types with several constructors. Product types can be Java's records, Haskell's data types with one constructor. Then Java's classes are also product types, C structs, and even tuples. So why are those two important? These are important because together they will enable exhaustive pattern matching and the construction and the composition pattern matching. But this is in the future for Java. And sealed classes and interfaces in Java is going to enable exhaustive pattern matching, which simply means in this case that if you have a switch case, for example, and you have implementations of an interface, all of them has to be covered in the switch case statement. That is exhaustive pattern matching. Destructuring means that you can pattern match on each parameter of the constructors in a class. Eric Dreyer, he wrote a blog which is very good about this thing. I recommend reading it for even deeper understanding of this. A simple example with Haskell. In the first example up here, I define a data type representing an animal. It can be dog, cat or an elk. This is an example of enum, enumeration. And in the second example down, I have a similar definition. However, I added one property, a string property there. And under it, you have a simple function that pattern matches on each type and its parameter there. This is my try to make the same example in Java. I use the enum again. And in the enum, I want you to notice one thing here, because in the Java enum, when defining like this, you see that all of the enums has to use the same constructor. So if you make a change to the enum, you need to change all of the enums here. So I want to show you this version now in Haskell. You see that each data constructor, the data constructor is what you see on the left, on the right side. On the left side, you have the type constructor. So animal is the type constructor. Dog, cat, elk, and unknown is the data constructor. And unknown is also called the nullary type. You see also that the first three data types here, they have different number of properties. And in the functions below, you see that, again, I'm pattern matching on each data type, and I can match on different which constructor parameter I want. The underscore here basically means ignore it. And the last function there, info, and the underline is basically otherwise. So records, you might have already heard a lot about this during the conference. Records are shallowly immutable data classes with named accessors. It's from Project Amber. I'm going to show you an example of how this is. Something familiar, you see that you see the named accessors on line 7, 8, and 9. Java creates those accessors, those getters for you as a part of the Java records. So this is how it is at the moment in Java. In Haskell, you do have records, however, it's different. But it's the structure on line 3 to 7 here is something called record syntax. And the record syntax, you can see the difference between the record syntax on line 3 and the regular data type definition on line 1. You name each field with the name and the type. And those names now, they will be the functions that you use in order to access the value that that data structure will contain. And you see on the line 9 to 12 here, you see how I use them, the accessors to access the values. Okay, but there is a problem, however, that is still being discussed in the Haskell. I have seen some issues in the issue trackers. Because of how global namespacing works in Haskell, you cannot have duplicate field names in Haskell. So when you have something like this, and you try to execute the code on line 10 down there, it will basically blow up and it will say, well, you have multiple declarations of the field accessor. So in order to enable this, you can enable it. You add a pragma on line 1. You activate the duplicate record fields in extension. And then you see down here what you have to do in order to tell Haskell which of those accessors is the correct accessor is by supplying you see A : person. You have to tell Haskell the correct type, because then Haskell will use the same function in that type. So in this case, from the person type. Sealed types. Sealed types has been really something I have been missing for a long time in Java, and it's finally a part of the language. It will bring Java a step closer to having algebraic data types. So an example from Haskell here, it defines automobile and I have abstracted automobile to a type class called transport. And then on line 13, you see that I extend the type class so that each automobile type will extend and also then inherit those functions, which is then as a part of the transport type class. I have a Java version of this. This same Java version of it would be something like this. So the record type that represents a specification, and then we have the interface. And Java's interface in this case here is what it would equal to Haskell's type class. Not entirely correct there, but in this case, it will be what is the resembles the most. And you see on line 11, it says sealed. When you seal an interface, you basically tell Java that only those classes that I permit can actually extend the automobile interface. And each of the classes that extends the sealed interface, they have to be final. And then there is one slightly surprising thing with Java's sealed types, and it's Java allows the non-sealed keyword. Non-sealed in this case means that if you have 3 specific types that you want to allow, but then you want to also allow a generic type, you can allow the generic type to be extended by other classes by supplying non-sealed to it. And on the link down there on line 21, Brian gets responded to one question on Stack Overflow, which explains why Java has the non-sealed. And imagine that you have you want to support plugins. You can support plugins by allowing other developers to extend the any class here. Okay, so inline classes. I am only going to talk about this very briefly. Calls like a class, acts like an int. This is something I took from Brian Getz again. So inline in Java really means that this code example, I saw it on the JEP, and Brian has also written about this. The idea is if you have primitives and you use primitives, when you add the inline keyword here, you can actually allow then the compiler to optimize your code by turning the compiler will inline, it will take those 2 ints and it will inline it in the container where the class is used. In Haskell also inlines as much as it can. For example, inlining turning the basic types that I showed you earlier into their equaling primitives in Haskell. In Java, the inlining would be something like this. This is very, very simplified. The class point and the 2 integers here, the class point is used in class line. When the inlining happens, the class point will, and the fields it contains, it will be a part of the class line. So you don't have that class point anymore in this context. And this will save you memory, it will save you process, and it will optimize Java to a whole nother level. And I'm really looking forward to this. I recommend a short video from Toby. He's one of the Valhalla expert group members. He made a video about inlining. I recommend you looking at this to understand this in depth. Okay, so modules and interfaces. In Java, spaces and tabs are ignored. Braces and semicolons are required. In Haskell, indentation matters, but braces and semicolons are optional. You see those 2 equal to each other. Very basic module in Haskell here. The first function simply adds 2 numbers. The second function just returns a string. In Haskell, this would be something that other developers would have reacted at. And it's really not how you should write the functions in Haskell. It's recommended to also supply the function declaration. The function declaration tells other people and you what problem are you trying to solve here. It will give you a view of it, and okay, so imports. Java imports Java lang by default. In Haskell, you will get the prelude imported by default. You can do, you have static import in Java. In Haskell, you do this by having a qualified import. But the reason for this, in the namespacing issue that I talked to you about, if you want to import 2 functions with the same name, but from 2 different modules, in order to avoid the name collision, you import it as qualified, and you prefix with a letter, and then you can access the function with that prefix and avoid the name collision. And the static import is actually the example under it with the parenthesis. Okay, so the modularization in Java, those are not entirely equal here, but the idea is the same. You have much more control of what is actually exposed and reachable by others. And additionally, we have private, public, protected, default, and static in Haskell. In Java, oh my God. In Haskell, this first part on the top here, this is what would be public and reachable by others. We enable this by mentioning them between the module keyword and the where keyword. There, everything that you mention between those 2 lines will be reachable. And you see that result here is an algebraic data type. By having the 2 dots after it in the parenthesis will allow also its values to be exported. So 1 lost draw will also be exported here. This part is the internals. It's going to be hidden and not reachable, since they are not mentioned above here. Okay, so here's an example of a type class. It's a parameterized type class. I tried to write something similar in Java there, generic interface. Those 2 would equal somehow. I would just underline here, Java does not have type class support, but the interface, generic interfaces would be what it will be equaling here. Here is one more extensive example. I simply modeled a person who can be either a teacher or a student. I have the person type, the parameterized person type class. I extend the person type class with each of those 2 types. And then you can see how I use the type class here. When I have a function on line 16 here, you see that I am accepting, since I have 2, since I have 2 student and teacher, those are 2 specific types. By having the type class, I am saying to the person that this function will accept either of 2 of them. And you can see the example in the main function here, how I use them. I can create specific types of each of the algorithmic types and access them. This is the same. I try to do the same in Java. Notice one thing, however, the difference in the length here. Control structures. Very basic type here. A person who can have a salary and 1 tax class for paying taxes. This is only a percentage number. I'm going to use this as a basis for the next examples. And this is a record syntax again. So let's start with the if, then, else. In Java, the if statements that you know is exactly statements. You can use them to do side effects. You can return from the if. You don't need to write the else if or the else. In Haskell, however, if is an expression. And expressions always has to result in a value. So you always need to also have the else. Haskell's if else can be rewritten. You can use something called guards, and it will be. I prefer using guards. It's more expressive. And then this example can be further rewritten into. You can use the where clause, and the thing I did here now in the function here is that I'm actually telling what problem am I solving here, and then I'm defining text class here to be one of those three cases. So it's going to be a if-else similar pattern matching here, and that where clause is going to return a value that is again used on the line 1. And Java has switch cases, as you know, and this is the old way of doing it. Luckily, we got the switch expressions now, which allows us to use the lambdas. And we can also use the switch statements as an expression, which means that you see on the Java side there in the second example, how I use the switch expression to return a value. This is equaling in Haskell has extremely powerful case handling. In Java, we also have, when using the switch expression, if you have multi-line cases, you can use yield. Using yield in a switch expression can make you return a value. And then I found something, and I request your help here. You can have multi-case pattern matching in Java. I didn't find a way to do multi-case on one-liner in Haskell. However, I found a way to do it with the lm function in this case. So if anyone has some ideas about this, talk to me later. I have some examples. On my examples on the net, I'm not going to go through all of them, but I wrote several versions of the case pattern matching in Haskell. So if you're interested, the code is online and you can take a look. There is several different ways of using, such as this example here, where I'm embedding the case pattern matching into the function here. Okay, so functional programming. Why isn't it more widely used throughout the world? First of all, Haskell, Java has a long history. In the very early of Java's life, there was a massive marketing campaign and Java industry adoption. It got adopted really, really quickly. Haskell is notoriously known for having a high learning curve, and the community is mainly around academia. And then there is object orientation. I would say that this probably is one of the most important reasons, maybe, why it's not that widely used. I'm going to show you a little bit of history here. We go all the way back to Algol 60. Algol 60 is one of the first procedural languages. And Algol inspired many languages that followed. You saw in Oslo, the researchers in Oslo created Simula, and Simula became the basis for Simula 67, which is the world's first object-oriented language. The first version of Simula drew some ideas from Algol 60, but in Simula 67, we had classes and many of the constructions that are familiar in the Java language today. And Java, as you may know, James Gosling also used Simula as one of his inspiration points when he created Java. So 70s, several new languages came along. And I would also mention during this time when the Unix operating system was being created and the object-oriented languages was used also to create graphical user interface applications. And then Java and the known languages. And in the in the end here, we see a shift because if you look at it like this, in the beginning we had procedural languages, then object-oriented languages, and then the multi-paradigm languages. The multi-paradigm languages allows you to not only code object-oriented, but you can also code functional. And I wonder now if functional programming is the future here. We'll see. Tooling. Java has an impressive tooling, and also as a consequence of the high industry adoption over many years now. Haskell still lacks tooling. That's why I used REPL it to show you my code examples here. And I hope for more adoption and better tooling support, because I look at Haskell as one very important language that can enable developers to be really write expressive code, but also inspire other languages. The JVM, well, the JVM is simply amazing. The JVM is supporting many languages. It's fast, and the hotspot compiler does some incredible optimizations. And we have, in the last few years, we have also seen stuff like GraalVM and many others extending. So the JVM is amazing, and it continues. And Java has one thing more that I'm very proud of, and it's the community. I mean, the worldwide community around Java is, and I'm a part of that global community myself. And this is something very important in order to further develop the language. And I see that I have some more time, so that's what I had. Is there any questions? Yes, sir. Yeah, so the question is, what is the benefits of functional programming in Haskell over Java? Yeah. I mean, the functional programming and object-oriented programming, they are two different paradigms. It's not a competition or anything between them. Object-oriented programming is important, and is going to still be used in many, many years to come. Object-oriented programming is not going to disappear or go anywhere. Even though we have those multi-paradigm languages and purely functional programming languages, you still will have object-oriented languages. So I mean, the thinking is totally different in functional programming. The thing with Haskell, I mean, this is just my personal opinion, but Haskell was very early on to innovate many things that we see in Haskell today. And Haskell is, I mean, there is languages that takes functional programming and some concepts even further than Haskell. And I mean, for me, who never worked with Haskell before I look at it 2 years ago, it was not that difficult to get started, because many people, they think Haskell, it's impossible. You need a PhD or something to do Haskell, but you really don't. I will tell you that I used Haskell in order to become a better Java programmer. For me personally, I'm still learning. I'm still learning because I want to be a better developer, and I believe that by looking at more, not only Haskell, but several other languages, you gradually become a better developer. I hope I answered your question. Any other questions? Yes? Yeah, so the question is if Scala has the features of Haskell or a superset. I only looked at Scala some years ago, and Scala has many things, but not all. I mean, I can take a look at it and hopefully give you a better answer. Any other questions? Yes? Yeah, so the question is if Haskell can become an enterprise language in order to be used more to create more enterprise language applications. Yeah, I mean, in the Norwegian industry where I work in Oslo, of course, Kotlin and Java is the two languages on the JVM that is mostly used. As I mentioned in the beginning, the biggest ad search engine in Oslo, they used Haskell. I am also inspired by the work they have done because they actually pushed the Haskell applications to production. And I mean, Haskell needs better tooling for sure. I don't think much will happen until the industry adopts it more. And in order for the industry to adapt more, I think we need a couple of things. First of all, we need a friendly, open, and welcoming and diverse community. That's the first thing. And I think that better tooling, as I said. I mean, I'm not entirely sure if enterprise applications is the right target for Haskell. I probably think, I mean, you might do it, but I wouldn't do it. I mean, that's my answer now. I don't know what the future will bring. But I think there is other tools that might do that job better. Yes?
Just back to the last question a bit, there are some like Facebook or Twitter or API that does have some products in production that are written by Haskell. Of course, it's not the main language, but they do use it in their solutions.
Yeah. And the fact that that companies and developers use it, I think is amazing. I mean, there is, even though it's not so obvious, and there is communities and systems specifically written with functional languages, and also in my community in Oslo. So, yeah. Is there any other questions? No? If you liked the talk, if I was able to bring something to you, please vote for me. And I thank you for having me. Thank you for being here today. I highly appreciate it. So thank you.